Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Hortonworks and Red Hat for sponsoring today's event. We appreciate their support of the Data Science Central community, and we're honored to have them both sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Cisco, Tableau, Oracle, Splunk, and Teradata, to name just a few. These past webinars are available on demand at Data Science Central, and if you have not had the opportunity to view them, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled Better Risk Management with Apache Hadoop and Red Hat. And before we begin, I'd like to just briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a few moments. We should have about 10 to 15 minutes for Q&A following the presentation, and this event is being taped and will be made available later on this afternoon. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I'll be your host for today's webinar. I'm very pleased to introduce today's speakers, Ajay Singh of Hortonworks and Vamsi Kemachagaji of Red Hat. Ajay is the Director of Technology Alliances at Hortonworks. He is responsible for design and validation of ecosystem solutions to optimally integrate, deploy, and operate Hortonworks data platform. Vamsi is Chief Architect of Red Hat's Financial Services vertical and responsible for driving Red Hat's technology vision from the client standpoint. His role is to work with the various clients to help them on key business transformation initiatives. He has a Bachelor's of Science in Computer Science and Engineering, as well as an MBA from the University of Maryland. Thanks for being with us this morning, you both, and looking forward to your presentation. The risk management system that each firm operates must respond not only to new recording requirements, but also handle ever-growing amounts of data to perform more comprehensive analysis. Most existing systems are not inherently designed to scale, thus many are inflexible and are also expensive to operate. In today's webinar, you will learn details on the modern data architecture for financial services risk management, use cases and best practices of how other financial services are using this MDA for risk management, and also solutions that can help organizations scale out, store real-time data with very low latency, and efficiently process and store huge volumes of data that support advanced analytics capabilities. So with that, Vamsi, I'm going to turn this over to you, and you can begin as soon as you're ready to go.
Great. Thanks, Tim, and good morning, good afternoon, good evening, everybody. Thank you for making the time to join us today. Again, as the title of the webinar suggests, we're going to talk about better risk management in banking using a joint Red Hat and Hortonworks solution that pertains to the big data space. But a quick look at the agenda. We'll start off talking about some of the current challenges that banking institutions face across a spectrum of the banking landscape. And then we'll talk about some of the common use cases that we're seeing out there. And then we'll then get into the technology details in terms of what are some of the data architectures that we as a joint partnership have been able to develop to solve the challenges and the business problems that our clients are facing in this space. And then we'll discuss quickly how you can get started on such an open and modern big data architecture solution. If you look at the banking industry post the financial crisis of 2008, you'll see that banking as itself, as its various areas of operation go, be it capital markets, investment banking, retail banking, wealth management, whatever have you, has been forced to reinvent itself. And this is due to a few major shifts in the world at large, as well as in the technology landscape. First and foremost, in certain areas of the industry, you're starting to look at increasing volumes. These could be volumes of stocks or equities or fixed income or whatever trading applications have you. They're starting to handle more and more increasing volumes of data. But while you have this move towards increasing volumes, you also have the traditional marketplaces your marketplaces where customers could, buy and sell, securities. These are changing to newer marketplaces, so you have not one or two, but maybe 20, 25 different areas in which, participants that want to basically involve in financial transactions can go in and conduct these operations. While you're doing all this, given the implications of what happened in 2008 with banking institutions not having enough collateral to cover for financial meltdowns as they happen, there's been an increased scrutiny in terms of how these firms operate. We're starting to see that due to regulatory pressures that are going up in the market, firms are starting to look at understanding their current financial products from an exposure perspective more and more closely. This leads to the whole risk and compliance bucket, which we'll talk about in a few minutes. But with all this, there's also the notion of doing more with less. So the margins on these transactions are shrinking, so are revenues, and so is profit. So there's a need to look at architectures or look at solutions that can save you on cost as well. And finally, to add to this, there's the complex business process itself. The number of participants in certain types of workflows are become more and more complex as time goes by. With that in mind, there is a need to develop architecture that can support complicated steps as transaction flow through systems, as you have more fraud concerns, more security concerns, whatever have you. So to essentially sum up, we are in kind of a perfect storm in financial services across all the different areas that make up banking. More of the scrutiny on risk, more of understanding of your current outstanding exposures with a view of setting aside adequate capital, and also more regulatory oversight. Banks now have to, across a ton of complex silos where they have data residing in, they have to be able to provide these risk reports and also be able to provide risk as a service to whoever is interested in analyzing it intraday or monthly or annually, et cetera. With all that being said, if you currently look at the different kinds of financial services workloads, at the outset, let me just say that IT as a whole and data systems are even more critical to the success of a bank than they were ever before. So the first use cases, or the bucket of use cases that you'll run into, is operational efficiency. And operational efficiency essentially pertains to those sets of use cases where you have existing architectures that serve existing or newer types of clients or existing stakeholders, but you have a pressure to do things better, more faster, and more cheaper in these areas without sacrificing service to your end customers. But once you have these architectures built in place, you also are looking to solve targeted pain points where you want to provide architectures that provide support for use cases like compliance, mobility as well. So Bank 3.0 is a big buzzword in banking these days. And the notion of Bank 3.0 is that your consumers as a whole have changed in the last 10, 20 years. You now have millennial customers who are more comfortable with not just walking into a bank branch as always, but also doing banking from their from their mobile clients. So the notion that banking is not some place you go to, but something you do is gathering more and more steam. But while you do that, the one thing you realize that every interaction that a client has with the banking institution is producing more and more data. So you have a pretty high volume of data that's being produced, and Ajay's going to talk about that in a minute. But you also have a tremendous velocity at which these data streams are moving into your architecture. And once these data streams move into your architecture, there's a huge need to not just ingest these at scale, but also to be able to look for patterns in this data and to be able to look for long-term patterns or even intraday patterns as the business case dictates, and to be able to provide support to downstream consumers. So the egress velocity as well is extremely high. So while you have these bucket 1 and bucket 2 use cases, you also are being forced to now develop new go-to-business models in banking. So the existing notion that banking is a 3-6-9 kind of a 3-6-3 kind of a model where you borrow at 3%, you lend at 6%, and you're at the golf course at 3 p.m. Right? That's changed now. banks are more and more looking like IT institutions. And with things like mobile payments, with things like multi-channel wealth management, you have a need to create new business models from all this existing data, all this existing integration. And the question then becomes, can your architecture scale? Can it really handle this and keep you on the curve for position your business for constant growth? So some of the existing architectural challenges from a data perspective, again, data is key to any information technology architecture. So you'll see that the slide is being headlined as data architecture, but really could mean information technology architecture challenges. The first challenge is homegrown and proprietary architectures. So a lot of the systems that banks have put in place, bank IT has put in place in the last 20, 30 years, have either been mainframe-based or server or three-tier architecture-based. But in a lot of cases, these are proprietary in nature in that most cases, from a data perspective, basically move the data to the compute, which has been a challenge in scalability and supporting newer types of deployment models like cloud computing. But while you have the challenge, the second issue is being that data needs are only growing. So I'm just going to talk about that in a minute. We see this volume challenge, exploding volumes challenge, as being pretty unique to financial services in addition to verticals like healthcare. But it's a challenge that architects and business leadership should be looking at solving, right? The third area is open and interoperable architectures. Whatever architecture you design to ingest this data, to process it, and to make it available to end consumers also has to play well with a variety of different hardware architectures and also with a variety of different open formats, be it a SQL-based method of accessing the data or maybe a RESTful or supporting a wide variety of back-end stacks that you currently have in place and to be able to play well with those. While you're doing all this, there are some buckets of use cases where you have to design with low latency and high performance in mind, in that not all data streams are suitable for batch-based access to data. For certain types of use cases or subset of use cases, data needs to be ingested and analyzed and reported upon virtually the same day, if not, for example, in high-frequency trading applications, you want a millisecond response time. But again, as an umbrella use cases go, low latency is desirable as much as possible. The other area is easy development, deployment, and management. I cannot stress how important this is. Whatever data architecture you put in place has to have package systems management, deployment support, and management support built in. And finally, the need to support a variety of different deployment models, be it supporting it on-prem on an existing bare metal infrastructure or being supported on a hypervisor-based infrastructure, or maybe even potentially an OpenStack or an Amazon AWS infrastructure as well. So the architecture should not be tied or bound to your choice of where you want to deploy all these different components, which are typically horizontally scalable and fault-tolerant. So having set the stage there, I'd like to turn it over to Ajay to talk about what he sees as being current currency in the industry from the perspective of existing systems and how they're being constrained by existing architectures that can't handle all this massive volumes of data. Ajay?
Well, thank you, Vamsi, and good morning, good afternoon, everybody. I will spend the next few slides here really talking about what we are seeing from an industry, from various industries' perspective. And being at Hortonworks, being one of the core team that is behind Apache Hadoop, we get the privilege of working with a lot of companies and really across industries. And there are certain things that we are now finding to be common across every project and opportunity that we work on. So let us just start with what we are seeing from a challenge perspective. Why are people adopting these new big data technologies? And really, to sum it down, the two common reasons for why people see adopting the new big data technologies is one, that their existing data platforms are siloed. So if you look at most enterprise applications today, they are built on the foundation of relational databases. And relational databases, with its inherent rigidity around schemas, tend to be very single purpose in nature. So you have one database for managing your customer relationship, you have another database for managing your ERP and supply chain data, you have another database for managing your products and parts information. So you really end up in a scenario where different lines of business within the same enterprise do not have full visibility of information and do not have the capability to truly analyze information across those different lines of business. And we see this especially in the financial services vertical, where you have conglomerate banks where the retail banking side doesn't know exactly what is going on in the investment banking side, and or is not aware of what's going on within the mortgage banking side. So being able to address silos of data is a challenge that we see a lot of our customers facing today, and they're using big data technologies to bridge that challenge. The second aspect of what we are seeing being played out in the industry right now is really an ability of the enterprise to deal with the new types of data. And really in our vocabulary, the new types of data is the Internet of Things data, the machine data, the sensor data, the web click data. Those are newer information types that enterprises are collecting just as an artifact of us now living in a more connected world and transacting online and in a connected fashion. We're generating a lot of exhaust information. And hidden in these exhaust information are patterns and insights that can be leveraged to drive additional business value. If you look at data technologies and platforms of the past, you soon realize that they were not built to really address the needs of this new data type, which tend to be semi-structured, which tends to have a lot of textual information in it, and it tends to come in large volumes and at great speed, right? So if you look at all of those attributes, you soon realize that the data platforms of the past weren't really meant and built grounds up to address that new type of data. And again, what we see at Hortonworks and what we see across our customers is enterprises are bringing big data technologies to address how they can more efficiently manage and mine information and intelligence that is contained within this new data types. So in terms of the business pain, some of this I already kind of talked through in the previous slide. In the previous slide, enterprises are going through the pain of and the challenges of dealing with data silos. They're dealing with the increasing volume. Even when you just look at what is happening from a transactional data perspective, what I personally call the run-of-business data, there is more of it, right? And with increased regulatory pressures, there is a need to keep more of it for longer periods of time. What that essentially ends up implying is that there is a very severe strain on your existing data platforms, whether that is a data warehouse and or that's a database. They are basically bursting at their seams. So being able to deal with just this increased volume of data and longer retention periods as mandated by various regulatory laws out there is really straining your existing data platforms. And finally, as I talked about in the previous slide, the existing platforms are simply not built to deal with this new types of data, the Internet of Things data, the machine data, and are really just struggling to be able to both store and, more importantly, analyze this new types of data. So what's come about as a solution to address the data silo and the growing data volumes that is being generated by machines is a new infrastructure a new data platform called Apache Hadoop. Apache Hadoop, as many of you guys are already probably aware of on this call, it started at Yahoo in 2005. And many of what enterprises, the regular enterprises and the classic enterprises are seeing today, the same challenges were being encountered by the web properties a few years back. And Yahoo in 2005 had a need to refine its infrastructure that it used to index the web and serve contextual data and contextual information to its user population. It had a very brittle system that it ended up replacing with Apache Hadoop. So Hadoop instantaneously brought to the table an ability to manage lots of data at a very cost-effective price point. Not only did it give you the ability to store and manage data, it brought about the ability to do batch analysis of data. So you could run analysis job overnight and then feed that information, feed the output of the analysis into your real-time systems for being served out to the end user as he or she visits the web properties. So Hadoop of 2 years back, it had the capabilities of being able to handle lots of data and do batch analysis of data, but it didn't have all the capabilities that enterprises need as of today, which is being able to not only do batch analysis of data, but to be able to do real-time and interactive analysis of data, to be able to do it all in the context of data being tightly governed and highly secure. So really what has come about in the open source community around Apache Hadoop is that Hadoop has transitioned in the last 2 years, I would say, from being primarily a batch-centric platform used by the web properties to now an enterprise-class data platform that gives you a myriad of capabilities that go well beyond just batch analysis of data. And that's really what we call the modern data architecture. So Hadoop as of today is no longer the Hadoop of 2 years back. Hadoop as of today, what we call the enterprise Hadoop, is a multi-tenant, multi-workload platform. And what I mean by that is, from multi-workload perspective, it can now support not only batch analysis of data, but it can also support interactive analysis of data and streaming analysis of data. So if you want to intercept a credit card transaction in real time to check for whether it's a fraudulent transaction or not and whether you should approve or deny the transaction, you can do so now using the tools that is available as part of the Hortonworks data platform. From a multi-tenant perspective, what has come about in the world of Hadoop, and really a lot of innovation that has come about in the last couple of years, has been to make Hadoop be highly secure, easy to manage, and properly govern the life cycle of the data that you are storing and managing within your Hadoop infrastructure. So it isn't just about being able to analyze the data. You also need to secure the data. You also need to govern the data. You also need to be able to easily manage your infrastructure without having PhDs running around in your data center. And that's really what Hadoop has come about to be as a result of last 2 years of community working on it. So the modern data architecture is all about having a common shared pool of data resources that you can securely keep within Hadoop, and then appropriately authorize different applications to be able to go against all that data where they have access, so they can glean insight and gain intelligence for the enterprise by analyzing vast amounts of both transactional data and machine-generated data. So if you look at Hadoop and the Hortonworks data platform, which is Apache Hadoop, tightly coupled, so enterprises can easily deploy it within their data center. If you look at Hadoop and you look at what Red Hat has to bring to the table, there's a very deep synergy between the two companies, between Hortonworks and Red Hat, and between the two offerings. So Hadoop today, one of the platforms, people deploy it on different OSs. The Hortonworks data platform runs on different OSs, but really the most popular one continues to be the Red Hat Linux, right? So many of our customers rely on the stability and the performance of Red Hat Linux to build their big data infrastructure. Now, as you go up the stack from the OS level, another layer of integration that exists between Hortonworks Data Platform and Red Hat is the Red Hat Storage Subsystem. So Red Hat Storage Subsystem brings POSIX compliance and multi-protocol support that can coexist with Apache HDFS to bring even a more expanded set of file system capabilities than what is natively available within Apache Hadoop. And really that's an area where our teams at Red Hat and Hortonworks have worked jointly together to make that integration be very tight. And then when you look at it from a user and a developer perspective, again, the entire suite of PaaS offerings from Red Hat is tightly integrated with the Hortonworks Data Platform. So you can both provision Hadoop in an environment of your choice, whether that is bare metal or it's virtualized. You can secure it to the extent that you want to, and Hadoop and Red Hat offers all the security capabilities that is required within sensitive environments, and especially within the financial services industry. And lastly, there are many software toolings available from Red Hat, such as the Data Grid, such as the rules engine, the JBoss rules engine, and those are all tightly integrated with the Hortonworks Data Platform. So together, the PaaS offering, the storage offering, the operating system offerings from Red Hat, and the Hadoop offering from Hortonworks provide the key building blocks for enterprises to roll out their big data platform. So with that, a quick overview of what's going on from an industry perspective, what we see people dealing with from a data challenges perspective, to how people are rolling out their big data strategy in conjunction with Red Hat and the Hortonworks Data Platform. I would now like to pass the ball back to Vamsi, who's going to walk us through some very concrete use cases of how the technology is being used within the financial services vertical. Vamsi?
Thanks, Ajay. So as Ajay mentioned, we're now going to spend some time talking about real-world financial services architectures that have been built to solve specific business challenges, as you'll see here today. But once we do that, we're going to then go back and deep dive on the liquidity risk architecture, or the risk management architecture, which we have implemented a few customer sites, and we are rolling that out as we see similar patterns of use being encountered by customers and clients, and their need to provide a flexible and an open architecture to solve those challenges. So the first architecture that we have here is a fraud detection architecture. As you all can imagine, fraud and in general, information security is a big challenge for a lot of financial companies at this point. And these are typically retail banking institutions that have operations like core banking or credit cards, and they have pretty highly automated and sophisticated business operations that they need to implement. But while they're doing that implementation, they want those activities to be secure, and the data flows to be compliant with whatever their internal security standards or external standards like PCI. So the architecture that is shown here was put in place for a credit card application. And essentially, the notion is that as credit card operations or transactions are done out in the field, these could be credit card swipes, e-commerce tickets, whatever have you, you want to basically get a complete view of any transaction and identify patterns in a group of transactions that could signify potential fraud. But while you do that, you want to also be able to target that customer or that transaction for personalized communication on improving services, as you will, once you get beyond, if a transaction is fraudulent or not. You want to basically use that as a way of driving loyalty programs or whatever have you. But while you do that, you want to be able to support multiple types of data feeds, as Ajay pointed out, these different silos of data. You want to not just support incoming transactions that are structured transactions in nature, or semi-structured in nature, or unstructured in nature. And once you have a lot of this data that's been generated, you want to aggregate the data, and then you want to basically perform analysis on it, be it machine learning or running MapReduce algorithms to basically target customers, to categorize customers, and to do better upsell and to drive better loyalty. or as well as to understand what transactions can cause you loss in terms of fraud. So if you look at this architecture end to end, you have information sources that are depicted on the left. These are a variety of different actors. These are machines or human actors, and these are transmitting thousands of real-time messages per second across all the different geos that the organization serves. The first tier of attack typically is a highly scalable messaging system, much like the messaging suite of technology that Red Hat provides. And the job of the messaging architecture is to basically bring these feeds into the architecture, but then once the feeds are brought in a highly scalable, horizontally scalable manner, you want to then normalize these feeds and send them in for further processing. The next tier that you'll run into typically is the complex event processing tier. And again, the goal of complex event processing is to process these feeds at scale and to understand the relationships between granular transactions and also be able to support the definition of these rules, whether they're fraud rules or they're security rules or they are loyalty rules, and being able to help business owners define these rules so that the platform can be opened up in non-technical users. And now once the data is in the system, you then want to do a couple of different things with it. Data that has high relevance for business needs to be kept offline or for batch processing, and typically the choice here was the Hortonworks data platform or building a data lake out, which is a repository long-term of all the different types of feeds that can be sent into the system. And then once the data is in the system, and once you have tackled the problem of real-time fraud detection, you want to be able to analyze this data, be it by machine learning or be it by MapReduce design patterns or whatever have you, applying these patterns on the data over a period of time to help understand what the long-term trends of the business are. And once the data is in that tier, it can be made available to business users via Hive or via Pig or whatever different languages that your analysts or your business users want to know and understand and use. The one last thing to mention about this architecture itself is that the rules component in the middle also includes a BPM server, and it's all embedded within the same platform. So when you have transactions that are analyzed by the complex event processing system according to specific business rules, for instance, one business rule could be that I know that the customers are running is if you have two transactions that happen within the space of an hour, and one is both of these are physical charges, and they happen in an area that is 100 miles or 50 miles or 80 miles apart in distance, then that's a potential fraudulent event. You want to call the customer and confirm with them that their card has not been stolen or otherwise hacked. That is a workflow. If you look at it, a call center person has to call the customer and then process a certain volume of these calls and be able to report back to his or her supervisor. That's where the BPM portion of the system comes in, and it really shines. So as you'll see here, through all these architectures, you're basically talking about bringing in complex application requirements and marrying that to heterogeneous data architecture with the Hortonworks data platform. The other use case is retail banking. Essentially, you have web applications that need fast response time. And in this use case, the use is more around the JBoss data grid component itself. So it's an in-memory grid of data. And you'll see that the way we position this with Hortonworks is that if your data is typically intraday, is typically the size of gigabytes, or data that can be fit into a JVM typically, you can use the JBoss data grid as that in-memory repository of data to be able to get to the data, to be able to analyze it, and to be able to perform distributed execution or MapReduce type analysis. But once the volumes of data start growing beyond intraday or T+1, T+2, we recommend the Hadoop, the Hortonworks data platform, as a repository of data so that data can be made available in HDFS for further processing. The other thing to keep in mind here is that the integration with the platform is bidirectional. So it's not just the JBoss data grid pushing data to the Hortonworks platform, but the Hortonworks platform, as a result of analysis, MapReduce or Hive or Pig, can also make data available and push it into JDG for use or by querying by customers who probably, or clients who are interested in typically fresher data itself. So the third use case is a global trading platform. This is basically being run by a large investment bank in the U.S. The goal here is to take a large trading application that's mainframe-based and to decouple it into a commodity x86 architecture. But while you do that, add in notions around big data. Solve the challenge that Ajay mentioned with heterogeneous data feeds, and to be able to incorporate them as part of decisioning in complex trading strategies. So the architecture here is you have an order management system, which is typically a web UI, but it could also be a partner system that can provide you data in an open messaging format, much like AMQP, which is the protocol of choice being used here. AMQP stands for Advanced Message Queuing Protocol, and it's being developed by different vendors, Microsoft, Red Hat included, as the lingua franca of financial messaging. So you have financial trading messages that are fixed in nature, fixed format messages that are being sent inside an AMQP payload, or you could have a human basically doing a buy-side order or a sell-side order, or whatever have you, on a terminal. But once the messages are sent in, they go through an enterprise service bus, and then they go through application of trading strategies to see what the best avenue to fulfill the order is, or the best execution route is, or the best price that the customer could get for that order. So do all the complex order matching logic that typically happens in a business rules solution. Now, once that's done, you want to then aggregate this data, but you obviously want to send it on to a downstream gateway or to a venue so that the order could be filled in by New York Stock Exchange or whatever dark pool or whatever that you use, system you use. But you also want to keep this data aggregated and this data present so that you can do retrospective analysis, and you also can do a lot of correlation and matching, which is typically done in an environment that supports a straight-through processing, right, which is the back-end workflow for securities reconciliation and satisfaction of the orders, right, or the booking of the orders themselves. For that, the customer basically used the Hortonworks data platform. And as you'll see here at the bottom of the picture, there's a three-tier architecture that could be designed as the best practice to satisfy, where is, or depending on the characteristics of the data itself, you want to either do a batching of the data, or as applicable, serve the data up using not just your typical MapReduce, but also things like Hive or Pig. And then you have a speed layer. And then the speed layer could be in-memory data grid. But this architecture is put in place in Hadoop Gen 1. But with Gen 2 of Hadoop and Yarn being coming to prominence now, it's interesting to see how this back-end problem or the bottom layer problem could be solved. And I'm sure the Hadoop community too has solutions here that could be leveraged in terms of stream processing or in-memory SQL or Stinger from Hortonworks or whatever have you. Now, again, these are all architectures that we could go on for a webinar in each of those, and it's our intention to come back to you all with more of these use cases, more architectures and demos as well. But with that being said, let's take a deeper look at one of the first architectures that we jointly put in place at a couple of customers. This is around the area of risk management and liquidity risk in particular. And this is a very topical item at this point in financial markets because the notion that you have a significantly increased regulation like Basel III or Dodd-Frank or the bank stress tests dictate that your current risk management system that's in place should not only be able to support existing reporting requirements that you have. These are reporting requirements are maybe not typically same day, or maybe they are they are going off of systems that were always tapped into. But now you want to handle this ever-growing source of information or new data, could be reference data, portfolio data, liquidity data, whatever have you, and you want to be able to put in place a scalable architecture. And the goal, again, here is twofold. Number one, you want to basically set aside capital in case there are certain unexpected cash outflows or some other market event that causes wider counterparty risk. So you want to be in a position that you are, as a counterparty, deemed to be trustworthy, that you have enough liquidity on hand among all the different positions that you have across a range of financial products. Once you do all that, you also want to be able to support dashboards and risk metrics that are analyzed by your regulator of choice or by internal risk management folks to ensure that reputation of the firm is kept intact. Now, a lot of these existing architectures are just not cutting it, right? Because you have a situation where these architectures do not support fresh data, or they do not support fast processing of the data itself. And these are all tightly coupled architectures as well. I mentioned the mainframe. There's also systems that are proprietary in nature, that are shrink-wrapped and tightly controlled, that don't support standard interfaces or a way to basically scale the architecture out in response to these heterogeneous data volumes. So with all that being kept in mind, what the customer here created is basically a modern architecture that supports a few different notions. And again, a lot of the notions that I discussed in the slide 2 or 3, which is to be able to support open interfaces, to be able to support different types of data. So you have structured, semi-structured data, so structured data that goes into an existing relational database. Maybe it's financial position data. But also market feeds are typically unstructured in nature, so what about that? And also semi-structured data, some other, maybe a proprietary kind of an XML type of lingua or type of schema that you need to onboard and process. You'll see that the data streams are shown on the left are basically producing this data among all the different systems of record. And once the data is pushed into the architecture, you have a two-fold architecture, a two-fold processing of the data that happens. Data is ingested, and you could do it in a couple of different ways. Here, the customer basically used messaging technology to pull the data in and pump it into the data lake that's being run inside a HTTP container. And depending on the use case, you could go a couple of different ways. You could basically prime the data grid, which is a key value storage of data, much like a NoSQL database, but think about it as an in-memory database. So it does not have a disk component to it natively. You can slap on a cache loader so that you can handle overflow data based on a certain policy. But typically, the data is kept alive or is resident in the JVM of the server. So the red icon shown here is basically a scale-out icon. So there's multiple nodes as it shows out there, and these are all x86 servers that are basically running a JVM, and with it, running the JBoss data grid. And then some of the data is being fed in here, depending on certain criteria, business criteria. But the data is also being fed into the Hortonworks data platform, which is the master repository of all the data feeds. And the canonical pattern here is data that is write once and write many times and read many times typically goes into the data grid. But the data that's written once and read many times is a potential candidate to go into the Hortonworks data platform. So once the data is made available, there's in-memory calculations that are being pushed out. So I mentioned the fact that a lot of these existing architectures push the data to the compute. But here, because of the underlying flexibility of the MapReduce framework and the smartness or the intelligence built into the Hadoop name nodes themselves, the mappers and the reducers are basically pushed to the proper nodes which have the data, and that's true for both the data grid and the Hortonworks data platform. And then these go in and basically do a bunch of complicated math, right? This could be value at risk calculations, what are simulations you want to run, min, max, standard deviation, et cetera, et cetera. But once these are done, the data is then made available in the data grid for use cases where the data needs to be queried for intraday or a day plus one. But longer term, the data is sitting in the Hortonworks data platform so that clients who use a BI tool can get to it via Hive, typically. And as applicable for certain partners who want to access the system using a BI tool, who may not have access to, who you don't want to give access to the data platform, which is a master here, you typically want to push some data off to RDBMS. And once you do that, the data is then made available using your standard data warehousing logic, right? So it's basically a fact table with multiple dimension tables, and then your business user can basically analyze the data using SQL queries and do a bunch of complicated aggregations and the typical ad hoc queries that they're used to. So again, from a high-level system architecture topology, at the core of the architecture is the Hortonworks data platform, which you'll see at the center. But you have a few different choices depending on what your volumes are. So if your volumes are going to be massive and you want to provide some kind of interception logic that can perform business rules in the data, you typically use something like a JBoss business process management system. But you also have the fuse component, which is the messaging component to pull this data in. So once you have the data sitting out on the data platform, and you have the data being seeded in from the messaging tier, some of the data, which is typically fresher, and you want to have a blazing fast response time of queries goes into the data grid itself, which supports the in-memory compute. So keep in mind here that the classical use case for using in-memory data grids could be as a store of the data, as a data grid, but using it as a compute grid is starting to be more and more of a popular use case. You have the data in memory, you typically want to go in and run some kind of processing on it. The other piece of the architecture, which we are building things like demos and quick starters on, is the virtualization platform that Red Hat supports. So the idea is that some data is sitting out, some data is sitting out in the data grid, some in the relational database. For all of this needs to be married with the master repository of data, which is the data lake, which is HDP. You basically want to offer queries across all these different layers of the data, and you want to be able to do it in a way that your consuming applications, which are shown at the top here, the application tier, can do so using a SQL query or a Hibernate call if it's a Java application, or a web service call, even potentially, right? So that capability is provided by the virtualization tier that lets you federate the data across all these different silos or different areas. So again, this basically is another slide which shows you what the runtime architecture looks like. And you'll see here the piece in the center, which is the HTTP, basically has all these different components running in, which provided a way to be that longer-term repository of data, so that you can then go in and run any kind of processing that Hadoop supports. So with that, I think we're up on time here. Let me just turn it over to Tim. Again, thank you for your time.
Great presentation. Both of you did a great job packing a lot of information in a short period of time and doing so very thoughtfully. So yes, we are at the Q&A portion of today's event. The slide that's up now includes Vamsi's and Ajay's email address. So anybody that is on the webinar today, you can take down their information, and following the webinar, if you'd like to reach out to them directly, please feel free to do so. So the first question, Vamsi, is going to be for you. Excuse me, sorry about that. In the beginning, you were talking about the connection with the recession and the increases in data and workloads and the relationship with equity in companies. Can you go into a little more detail about that? The viewer just would like a little bit more depth, if that's possible.
Sure. So maybe I conflated both, but let me take a step back and explain where I was going with that. So from a business vector perspective, you basically have two different things that happen. Number one, with the recession, you had a tremendous amount of market volatility. So you had a situation where data feeds typically, or the volume in the market, would go up or down in those first 2 years based on market conditions. And you had a lot of stressful market events where the markets increase or drop, whatever have you. So you had that was going on. But what you got out of the recession was an increased focus on risk and compliance. So this architecture that we showed you would not have been possible with pre-2008 market conditions. I mean, the requirements just weren't there, right? Now, because of the recession and the fact that there's an increased focus on what banks are doing with the data they have, you then have the notion that you had to, as a banking institution, understand all these different data categories that you had, while also being able to onboard data from different other parts of the organization to be able to create these risk reports in real time. So you have that as well, which was a consequence, indirect consequence, some might say, of the increased data in these workloads because of increased volumes of data that your equity and fixed income or commodities volumes that you were processing. Again, they're all interwoven business trends, but what you got out of that is higher regulation means there are more requirements to know and understand and sift through your data, but also higher volumes, which means that you have to not just ingest all these volumes and also process them at quick speed. So existing RDBMSs weren't just going to cut it at that point.
Excellent. Thank you for that thoughtful response, Vamsi. So this next question is for Ajay. Do you need RDBMS for Hadoop if you are not yet an enterprise? I'm not quite clear of its value, thinking that Hive already provides this data summarization. So can you address that, Ajay?
Yeah, definitely. So is there a need for an RDBMS when you already have Hadoop and Hive? The short answer to that is yes, right? Hive gives you a lot of analytical capabilities, but the maturity of transactional capabilities that is available within your relational database systems, it's not there within Apache Hadoop and Apache components as of this point in time. So really what we see is that most of the enterprise applications that have been written on relational database systems, they are continuing to be on relational database systems. So you're not really trying to rip and replace the RDBMS, so to say. But now you are starting to collect data from all these different enterprise applications that are running on RDBMS into a common consolidated data lake, which is built on top of Hadoop. So you get visibility across the full set of information, and you get the ability to analyze the information in its entirety, right? So to summarize it, yes, you still need RDBMS. Most companies are not re-platforming their enterprise applications, but rather they're taking an architecture where they pull data from different RDBMS into a consolidated data lake.
Very good. Thanks for that answer. This next question is, we've had a couple of questions on the security issues, given recent breaches that we all hear about. Ajay, I'm going to start with you since you just finished that question. If you can kind of talk about how security is being taken into consideration and measures to protect data, both internally and then externally, and then maybe after Ajay, you can ask me, maybe you can address the same question.
Sure. So first and foremost, security is a key area of focus for the community. We fully understand that there are certain industries where without security there will be no adoption of Hadoop, period. Right. So with that realization, the community over the last 2 years has been hard at work to bring in all the layers of security that is needed and expected of an enterprise class data platform. So when you think about security in context of any data system, there are certain aspects of security that you need to take care of. One, authentication, right? So when Ajay logs into the system, he's strongly authenticated to be Ajay. Ajay cannot fake to be somebody else. Then there is this notion of authorization. Once Ajay gets into the system, what units of information, what information assets does he have access to? Because not everybody within an enterprise gets access to all the data set, right? So that's the authorization piece of it. The third piece of security is encryption. So when you store information within your data lake, you have the ability to encrypt the data as it is on the disk. So people cannot, or somebody cannot just walk away with the disk and get to the sensitive information. That communication over the wire is encrypted. right? So nobody can sniff into the network and get to the sensitive data. And also that you have the ability to tokenize and mask certain fields of data because not everybody needs access to those fields. For instance, you may choose to mask the social security number, so only the last 4 digits are visible to the call center operators, right? So that's on the encryption side. Then you need an ability to audit what is going on within your system, who has access to what data, who has made what changes. You need full audit of all actions within your system. And finally, you need an easy way to administer all of this, right? You need an easy way to administer authentication, i.e. hook up with your enterprise identity management solution, easy way to authorize, easy way to encrypt, easy way to audit. And today, as part of Hortonworks Data Platform, we are bringing together all of those capabilities in an easy-to-use packaging, right? So really, we have looked at security in its entirety and every nuance of it. And today, working in the open source, we are delivering on all of those aspects as part of the Hortonworks Data Platform. Our thrust going forward as a community and as a big data platform is really even to make things be more simpler. So today the capabilities are all there. It's fairly easy. We have made significant strides, but we can make things even more simpler, and that's where the community is focused at this particular point in time. Vamsi, would you like to add something?
Sure, Ajay. Thank you for that response. So from the perspective of security, which is obviously a huge topic, as Ajay pointed out, all the pieces of the architecture that make up this architecture support enterprise-grade security, right? So you have security, the authentication, are the users who they're saying they are, authorization, a set of permissions that percolate from system to system, while at the same time supporting encrypted secure communication, right? So when data moves, data is in motion, data is encrypted. We have standard TLS or whatever have you, and you have a handshake mechanism, certificates, et cetera. But when data is at rest as well, the data can be encrypted. And if you have attacks that happen via rogue processes trying to join existing clusters or existing infrastructure, you have a process whereby you can basically reject that and then flag that node and basically, jail it off or whatever have you, right? So you can do that. So there's, again, a variety of mechanisms that have been put in place. But it really comes down to the overall architecture and also the culture that you have. It's not entirely a technical problem. That's what I like to think of it, as Ajay pointed out. But all the pieces are there, and they're all robust, and they've been proven out in enterprise deployments.
Okay, excellent. We have just a little bit of time left, and I want to make sure we get to several questions that have come in with the idea of how does someone get started with Hadoop and in this process. Can you guys just give a quick overview of what someone might do if they're just looking to jump into this sort of category of Hadoop?
Ajay, do you want to take that?
Sorry, could you repeat that question?
Sure, sorry about that. So just there have been several questions about how one would get started. Can you guys give a little bit of an overview of someone's initial steps that would be the smart ones to take?
Yeah. So the easiest and the smartest step that you can take to get started with Hadoop would be to go and download the Hortonworks Sandbox. So what is Hortonworks Sandbox? It's nothing but a VM with Apache Hadoop and the Hortonworks Data Platform pre-installed. So you don't have to go through the process of setting up the software. It comes pre-installed. And the second and perhaps even the more important aspect about the Hortonworks Sandbox is that it comes preloaded with a suite of tutorials. So all the way from beginner's tutorial to intermediate to advanced tutorials that you can leverage to get self-trained in the technology of Hadoop, right? So that is really the easiest and the most effective way to get started with your journey of learning big data and more specifically Apache Hadoop.
Okay, very good. You guys did a great job, a wonderful presentation. I just have a couple of quick announcements to make as we wrap up today's webinar. Please mark your calendars for March 17th and our next Data Science Central webinar, Predictive Analytics, Rethinking How You Process Big Data, sponsored by Angos. Also, as I mentioned, this event is being taped and will be put live onto Data Science Central later on this afternoon and can be viewed for on demand. This brings our webinar to a close. I'd like to thank our audience for their thoughtful questions. And by the way, any questions that were asked, of which we had plenty that didn't get answered, rest assured, all of them are being sent to Ajay and Vamsi to be replied to later on. I want to thank our sponsors, Hortonworks and Red Hat, for sponsoring today's webinar, and a special thank you to both Ajay and Vamsi for their insight into today's topic. My name is Tim Madison. I'm very pleased to have been your host for today's webinar, and I look forward to seeing you all again on March 17th. Good day.